On the 12th day of Christmas, Mr. Ing gave to me 12 perfect scores, 11 lessons learning, 10 steps for factoring 9.
Hey guys, let's go over 4.4 graphing a square root inequality. So let's say they ask you to graph y is less than the square root of 2x plus 5. I'm going to show you in the first way we just previously learned about finding the characteristics. So this will be the x and the y-intercept. So I'm going to show you that one first. Okay, so an x-intercept means we make the y values 0. So, and then don't get intimidated by the inequality sign, just make it like an equal sign. And then you just solve for this, right? Just take the square on both sides. You have 2x plus 5, subtract 5, and then divide by 2. And you get x equals negative 5 halves. Okay, so that would be the order pair negative 5 halves, 0. All right, if you do the same thing for the y-intercept, you're going to make x equals 0. So just take your equation, make the inequality equal sign. So we should have 2 times 0 plus 5. So that will just give you 0 plus 5, which is the square root of 5. So this would be your let's make a quick sketch of this graph. Okay, the white one is negative 2.5. And square root of 5 is like, I don't know, more than 2. So your graph's going to look something like this. Okay, now this one means dashed, which means that anything on here is not a solution. So go through this one now. Okay, and then the next thing you're gonna have to figure out is where to shade. So the nice thing is you can just test the region 0. So if I put in 0, 0, testing this point, it's going to tell me if I'm going to shade or not. And then 0 is smaller than square root of 5. That is true. Let's just make sure we understand that. So let's say you pick, let's test this point here. 1, negative 1. So if I put in negative 1, this negative 1 smaller than the square root of 7. Okay, so that means that even in the green region that we tested is also, so everything down here is now where our solutions are. Okay, let me now teach you guys a second way of graphing this, and that is by our transformations. Because you just learned about the transformations. Okay, on the original equation, you have y is less than 2x plus 5. And I want to argue, because that's called argument, 2x plus 5 is the same thing as x equals negative 5 halves. And so what I'm trying to say is that x x plus 5 halves, this is the same. Now, why did I write it that way? Is so that I can do this. Okay, so if you write the form that we just learned previously, notice that is inside. So let me just write the whole thing. F of x equals a times b x minus c plus d. Okay, so there's no a, there's nothing out here, so no a. There's nothing in front of the parentheses, there's no b. There's nothing outside to the right, so there's no d. So it's just a c value. Now pay attention. That means your c value is 5/2. And if the c value is 5/2, we just learned that if c is greater than 0, then you're going to go to the right 5/2. Oops. Okay, my c value is negative 5/2. So if c is less than 0, then we go to the left. Add to x, go west, left. So that makes sense, because if you're going left 5/2, if you go back up to our graph, there it is right there. And then you could just do the shading. So two ways: you can either do x and y intercepts, or you can do the transformations. Okay, question number 22. Let's go ahead and graph that. Let's do it by the intercepts. So let's just make the y value 0. Let's just solve for it. So I'm just going to square it. Get 0 is less than x minus 5 or equals 2. And then you get x equals 5. So 5 comma 0 is our first one. Okay, so then if I do a y-intercept, I make x 0. And then I'm going to get the square root of negative 5. Okay, so remember, this is a complex, which means there is no real solution, which means that no y-intercept. Okay, so let's go ahead and graph this really quickly. So now if I go to 5, 0, okay, your graph's going to look something like this. And then you have, this one is just less than, so it's going to be dashed. So dashed. And then let's go ahead and test our shading. Okay, we can test 0, 0 here. Okay, so if I test it, 0 less than 0 minus 5, 0 is smaller than the square root of negative 5. Is 0 smaller than a square root of a negative number? That's not possible. Okay, let's go ahead and test a point. Let's say, we pick a number like, say 7. 7, 0. Is 0 smaller than that number that is true? So we're going to shade in this region. Or if that number is just keep going down there. Okay. But I also want to show you why this point would not work. Say 0. This is not true. 0 is not smaller than a square root of a negative number. That'll be complex, so it would not work. So that would be false. And that's why you don't shade on the 0, 0 side. Okay, if you did it by transformations, you basically just this one you're just going right 5. And that would make sense because you're just going off here by 5. And then you would just do your test points. The x and y intercepts are important because in pre-calc you guys are going to have to find the characteristics. Okay, number 23. Remember, you can do this quickly by the x-intercept, making the y 0. Square both sides, and you'll get x equals -6. And then you have the y-intercept, make x equals 0. So you have the y value, so -6, 0, and 0, square root of 6. So make a quick sketch. -6. Again, this one's going to be dashed. Can't read that. Dashed. Because there's no equal sign. And then let's just pick a point to shade. Let's try 0. Is 0 bigger than the square root of 6? This would be false. So no over here, that means yes over here. So you're shading this region above. Okay, again, if you did transformations, add to x, go west, so west or left 6. And that makes sense because you're going 6 units there and do the test point. So transformations are easy when you only have like one thing in there, but when you have multiple ones, it's not fun. Okay, number 24. Let's find the x-intercept. We're going to make y 0. Divided by -4, that's still 0. Square it, still 0. And then you get x equals -3. Okay, let's find the y-intercept. Let's make x equals 0. Remember, we're just putting it as equal sign, so it's something we can work with. And then you're going to have -4 times the square root of 3. So 0, -4. So you just know it's a negative number. Let's graph it. Okay, -3. Okay, pay attention. This one is negative. Okay. And then also pay attention. This one's going to be a solid. Why? Because you have the equal sign. Okay. So it's not just this. Let's fill it in really nice. It's going to be solid. Okay. All right. How do I get that by transformations? Number 1, your C value is -3. Remember, the formula has x minus C. So to get that to work, you would have to do that. That's why I see it as -3. So you're going to go left 3 units, which is true, because you went like that. Okay, what does this -4 do? The -4 is on the outside. This is your A. So your A value is -4. So if it's negative, then it's going to reflect over the x-axis. That's essentially what we've done here. This is my x-axis. I mean, it's here, but then it's like mirroring over. So now it's the white one. Okay, let's go ahead and test some points here. Let's go ahead and test 0. Is 0 bigger than some negative number? That would be true. 0 is bigger than a negative number, so we just tested this. So that means, you know, all of this in green is going to be a solution. Okay. All right, let's try number 25. Let's find the x-intercept by making y 0. Divide by -2, it's still 0. Square it, still 0. X is equal to 6. Okay, let's do the same thing for the y-intercept now. Make x 0. Okay, so you're going to have a complex, so no real means no y-intercept. Okay, let's get a graph. I got that green color, 6, 0. Okay. Now, I don't have other points. So what you could do is you just maybe put in 7, a table of values. That's another problem. Just want to see what would happen, right? So x is 7, so 7 minus 6 is 1. Square root of 1 is 1. 1 times -2 is -2. So 7, -2. So my graph's going to go... That's 7. This is -2. So my graph's like this. Okay, this is going to be a solid because you have the equal sign. And your graph does this. Now, how do we know that? Well, by transformations, you can go back and you should be able to identify that the letter on the outside of the radical, if your A is less than 0, so A is negative, right? Then it's going to reflect over x-axis. And then we can just go ahead and test something. Let's test 7 negative. Let's do 7. Let's do 7, 3. Let's test 7, 3. So 3 less than -2 times 7 minus 6. So that'll be square root of 1 is 1. So is 3 smaller than a negative number? And that would be false. So 7, 3, we tested up here. It was false, so no. Okay, what does this mean? That means, get another color over here. We should test, we should shade this region. Okay. So other side of the, okay. Number 26. Let's find our x-intercept. Let's make the y 0. So when you look at this one, you can treat it like this box here. Think of like 2x minus 5. So normally you would just add 5 to both sides. Then divide it by 2. Okay, then we would square it. So then you would get 25 over 4 equals x, and then 25 over 4 minus 7 equals your x value. So, you could just put it into a calculator. Let me put it in mine. So 25 divided by 4 minus 7 gives me negative 0.75. I guess I could have done something like that, right? 25 minus 28 over 4. So that'll give us negative 3/4. So this would be my x-intercept. Okay. Y-intercept, same thing. Make x 0. So you can just put that in your calculator. That one's going to be a little bit harder. I got 0.29. Okay, let's make a graph. Okay, negative or positive 0.29. Okay. And then the white, you have negative 0.75. Try to make that more clear. Okay. And then I know it's going to be dashed because there's nothing below that one. Okay, so let's do our test point. The easiest one is 0, 0. So 0 less greater than 2. 0 plus 7 minus 5. Okay, so 2 radical 7 minus 5, which we already did, was like 0.29. So is 0 bigger than, no money is it bigger than 29 cents? That would be false. So no over here, that means we're going to graph up there. Okay, and you can confirm that with your favorite graph. If you did transformations for this one, this one will be a little bit crazy. This is, let's just write it out. A x minus c b value plus d. Okay, so this is down 5. Remember, this is minus minus, so c value would be negative 7. Add to x, go west, so it's left 7. Okay, and then a dilation, vertical dilation, it's bigger, but that's probably the big one. So the vertex, or the point there, usually at the origin, you're going to go, let's try a different color, pink here. You're going to go left 7, and then down, and essentially you would have the same graph. Guess we're just way out here, but it goes at negative 0.75. Okay, last one, 27. X-intercept, orange. So 0's equal to 4 times x minus 2 minus 12. And 12. Again, I'm treating the square root like an x. Divide by 4. Square it. And get x equals 11. Okay, let's do our y-intercept. Okay, already we have a negative, which means going to be complex, which means no y-intercept. Let's graph this. Okay, so we have 11, 0 way out here. And no y-intercept. So all we know is it's positive. It's not flipped over the x-axis, it's not flipped over the y-axis because your b and your c values are positive. So we think the graph might be something like this, but we can confirm that. You can make a table of values. You can make a, let's try that. I'll show you guys. Okay, so if I put in, I can't put 0, can't put 1. If I put in 2, you get 2 minus 2 is 0, square root of 0, times 4 is 0, 0. So then you get, so that should be a 2. That should be a negative 12. So something way down there, right? If you put in a 3, 3 minus 2 is 1, square root is 1, 1 minus 4 is 1, so negative 8. And then you could put like, I don't know, 11. Well, we already know what the answer is. 11 minus 2 is 9, square root is 3, 3 minus 3 times 3 times 4 is 12, 12 minus 12 is 0. The same thing. Well, that's not going to be nice. But you get the idea. Maybe 18. 18 minus 2 is 16. Square root of 16 is 4. 4 times 16. 16 minus 4. So 18 and 4. So gives you an idea. Okay. Now we want to test it. So let's test it. Let's pick 0. So let's test it. 0, 4 times 0 minus 2 minus 12. And already, you know, you have a complex here. So that's going to be a no BL solution, which means this is false automatically. Okay, so that region though, I know you're going to say, well, maybe it's yes over here, but let's just test it. Let's pick something like 12. Let's test 12. So 12, 0. So guess I should pick the easier number. Let's test 18. 18, 0. And I chose that because it's going to be 18 minus 2 is 16. So this would be square root of 4. Square root of 16 is 4, so 16 minus 12 is 0, bigger than 4. This would be false. So this is no. This is no. So where can you go? You're going to have above. And that should make sense because it says y is what? Greater than, it's above. So you can test a point up there. Let's test like 11, 4. You can strategically pick a number. Yeah, 11 is fine. Let's try 11, 4. Another color here. Just proving to you why that works. So 4 is a y value. 4 times 11 minus 2 minus 12. So 11 minus 2 is 9. Square root of 9 is 3. So you'll get this. 4 is greater than, so that would be true. That says true. Wow. So yes, you're going to shade in that region. Okay, how do you do it by transformations? Remember, x minus c plus d. So you have a vertical stretch. Factor of stretch by 4. Okay, you're going down. So down 12. And then your C value is 2. So if it's bigger than, you're actually going to the right. So essentially what we have is something like, no, there. And that matches our graph. So our graph should again be solid. And that's how you do it. All right, we'll see you guys later. Bye.
Math is my favorite subject and a very challenging class.